Okay, pre-calc students. So that was a little guitar introduction that I do a lot of times when I make these videos. This is going to be a section we're going to be talking about functions. Okay, so things that you learn typically in college algebra. So a function is a relation in which each possible input value leads to exactly one output value. That's real key. We say the output is a function of the input. Okay, the input values make up the domain, the output values make up the range. So the domain of a function is the set of the first elements in a Cartesian plane, meaning when we graph, this is the set of all x values. And the range of a function is the set of all second elements. So if we graph something in an xy plane, known as the Cartesian plane, the range is really the y values. So if you take this definition of a function, if you look at what we call a mapping diagram, you have your inputs, which is your domain, and then you have your outputs. And you're always asking this question. Does each element in the domain map to exactly one element in the range? So if you look at this, -2 maps one time. -1 maps one time. 0 and so forth. So every element in the input matches up with one element and only one element in the output. So that would be yes. Is this relation a function? Yes, it is. Okay, second one, another mapping diagram. We ask the same question. Does each element in the domain map to exactly one element in the range? -2 maps one time. -1 maps one time. 0 one time. 1 one time. 2 one time. Okay, so that's yes. So that would also be a function. Okay, now notice that you can be a function and you can have a different number of elements in the range than you do the domain. That's not what matters. Okay, look at this one. Same question. Does each element in the domain map to exactly one element in the range? Well, the 0 does, but here's the problem. The 1 maps to two different values, so that makes it a no. Notice also that the 4 maps to 2 and the 9 maps to 2, so that would not be a function. Okay? Okay, so what I'll have you all do a lot in these videos, a lot of times I just have you try some problems. So I'm going to have you pause the video and try this example 1, example 2, example 3, and example 4. And pause the video when you're ready to resume the video, and then I'll have the answers posted. Okay, so here's the answers you should have got. Example 1, this is a function. The domain is the set of all of the x values, and you just write the domain like this. The range is the set of all y values. Now what you do is you write this in a set brace. When you list out a domain and a range, you list it in braces. Okay, that's the correct way to do that. Okay. Now this example 2, okay, it doesn't have to be numbers. It can be names. It can be letters, shapes, all kinds of things. So this is a function, yes. The domain is Ken, Carl, and Lewis. The range is Kathy. Okay, and again, every element in the input goes to one element in the output. So in other words, I'll look at this, I think all of these 3 guys, they are really into Kathy. So that is a function, okay? They really like that girl. But when you get to example 3, this is not a function. Okay, the domain's Jerry. The range is Abigail, Barbie, and Jill. However, Jerry is a bad boy. Jerry has 3 different girlfriends. That's not a function. Okay, that's one way to look at that. Okay, next one. Is this a function? Yes, because the -2 maps to one thing. -1 goes to one number, and so forth. Domain would be -2, -1, 0, 1, and 2. Now the range, you don't say 2, 4, 2, 4, 2. You just tell me what those 2 numbers are. Okay, so that's what you should have come up with. Okay, moving to the next page, we'll talk about what a one-to-one function is. And a one-to-one function, the definition is opposite of what a function is. So it says a function's one-to-one if each element in the range, or the output, corresponds to exactly one element in the domain, the input. So you're just really doing this in reverse. In a one-to-one function, each y value corresponds to exactly one x value. And the definition is essentially the reverse of the definition of a function. A relation is a function if each x value corresponds to exactly one y value. So the best way to look at this is just look at some of these examples. Okay, first thing we're going to do is ask the question, does each x value correspond to one y? Okay, 2 corresponds to 6, 5 corresponds to 15, 10 to 30, so that's yes. So this is a function. Now we're going to ask this question. We're going to ask it backwards. Does each y correspond to 1x? So does 6 correspond to 1x? Yes. It goes to 2. Does 15 correspond to 1x? Yes. Does 30 correspond to 1x? Yes. So that means that this is a one-to-one function. Okay, that's what they look like. Okay, next one. Does each x correspond to one y? The 5 corresponds to 2, the 7 corresponds to 0, 8 corresponds to 1, 10 corresponds to 2. Yes. So this is an example of a function. Now we ask it backwards. Does each y correspond to 1x? Okay, well, let's see. The 0 goes backwards to a 7. The 1 goes backwards to an 8. But here's the problem. The 2 maps back to 5 and to 10. That's a problem. So although this is a function, it's not a one-to-one function. Okay. Okay, next problem. Does each x correspond to one y? Okay, here you got a problem right there. The -2 corresponds to 2 values. It maps to 1 and it maps to 3. So that is not a function. And if it's not a function, then it's not going to be one-to-one. So you don't have to really think that much about that. Okay, one-to-one has to be a function. Okay. Next problem, next page, same question. Does each x correspond to one y? The answer is no, because look at that 35. It maps to a 1, maps to a 22, so this is not a function. So that means this is not a one-to-one function. Okay, if you did look at the one-to-one function, you'd be asking the question, does every y have one x? And notice the 1 maps backwards to -35, and it also maps backwards to 0. Okay, so I'm going to let you all pause the recording and see if you can do these 3 problems. Okay, pause. When you're ready to check, the answers will be up. Okay, so here's what you should have come up with. Problem number 1 is a function, or no, it's not a function and it's not one-to-one. The problem is that this 1 corresponds to 2 different y's. And if you look at it in reverse, you have a problem with the 10. The 10 maps backwards to a 5, and it also maps backwards to 0, so it's not one-to-one. Number 2, does each x correspond to one y? That's yes. The relation is a function, but if you do it backwards and ask the question, does each y correspond to one x? It does not. That 7 maps backwards to 2 values. And the last one, is it a function? It is a function. Every x has one y, but if you go in reverse, the 3 is what causes the problem. So if you start with a element in the range, an output of 3, that maps backwards to -2 and to 2. So that's why it's not one-to-one. Okay, so that's the first thing you're studying about functions. You want to know what they are. You want to know what one-to-one functions are also. Okay, so if you look at graphs, you can tell a graph is a function or not, and you can also tell if it's one-to-one by doing the vertical line test and the horizontal line test. So the vertical line test says any vertical line drawn will intersect the graph at only one point. Okay, in order to pass the horizontal line test, any horizontal line will intersect the graph at one point. So here's kind of these examples right here. This one fails the vertical line test. And what it's doing is these 2 points right here have the same x, but they have 2 different y values. And you can't have that. So the vertical line test is to check and see if it's a function. Okay, you look at the next problem, the vertical line, it does pass the vertical line test. Every x has one y, but it fails the horizontal line test. So it's not a one-to-one function. And this third one would pass both. All of the vertical lines go through one point, so it passes. That means it's a function. Horizontal line test, if you take horizontal lines, it'll only go through one point. Passes that also, so it is one-to-one. Okay? So we'll run through this pretty quickly, and let's take a look at this then. So we're given this graph. Now you want to assume that this graph goes on forever in both directions. Does it pass the vertical line test? Yeah, if you take any vertical line, it'll only go through one point, so that's yes. So that means this is a function. Okay, what we're doing is finding every x, and when we do a vertical line, see what we're doing is we're identifying that x value, and we're just making sure that it doesn't have 2 y values, 2 or more y values. Okay, now let's look at whether it passes the horizontal line test. Well, all you got to do is find one place. Notice this horizontal line goes through 2 places, so it does not pass that. So that means this is not one-to-one. This is not a one-to-one function. Okay, next problem, does it pass the vertical line test? Yes. Okay, again, what we're doing is we're seeing that every x only has 1 point, only has 1 y value. So this is a function. Horizontal line test, if you just start drawing horizontal lines, they only go through 1 point. So this one is a one-to-one function. Okay, so like this first one is not one-to-one. First one is, the second one is one-to-one. Okay, so I'll let you guys pause the recording and do these 3. Pause, and when you're done, see if you did okay. So here's the answers. Problem number 1 is not a function, and it's not one-to-one. Fails both tests. Number 2 is a function, and it is one-to-one. Passes both tests. Number 3 is kind of interesting. It does pass the vertical line test, so it is a function. But if I say pass the horizontal line test, this line is already horizontal. So if you take that horizontal line through there, it's going to intersect an infinite number of points. So it fails the horizontal line test very miserably. That's how that works. Okay. All right. So next thing is we're going to look at evaluating a function. So this, the function notation that you've seen before, we usually write this like this, and we read that as f of x. You'll see me always kind of write the f not in a traditional way, but something more like that, kind of like an italic. Okay, or if you had something like g of t, that just means the function's name is g and the main variable is t. So when you're evaluating a function, all in the world you're doing is you're doing arithmetic. So we're going to take that -2 and we're going to evaluate it. So we're going to take that number squared minus 3 times that number plus 1. Now, one thing I always tell students to do is get your framework built, then put in the number. Okay, now you got to follow order of operations. Negative 2 to the second is 4, because it's negative 2 times negative 2. Negative 3 times negative 2 is plus 6. Add that together, so we would get 11. And all this really means is if you graphed this function, you would have a point negative 2, 11 would be on the graph. That's what that means. You're finding the y value given the x value. So that's the x value. F of negative 2 is the y value. Okay, the next one, we're going to do g of negative 0.25. So we're going to do 6 times negative 0.25 squared minus 4 times negative 0.25 plus 6. Okay, and again, you can take your calculator and do this if you want to. So if you take like negative 0.25 times itself, you're going to get 0.0625. So we're going to have 6 times 0.0625. If you take 4 times 0.25, that'll be plus 1. Again, you can use your calculator if you want to. Then if we take 6 times 0.0625, that will give 0.375. 1 plus 6 is 7, so this would evaluate as 7.375 would be what that answer is. Right? So it's arithmetic, but you have to know how to do order of operations. And, a student in this level of a class generally is already going to know how to do order of operations. If you don't know how to do order of operations, well, you live in the 21st century. And what you can do is you can go Google order of operations, find you tons of videos that will help you tremendously. So these are the good days to be a student. All information's at your fingertips. Okay, next problem, h of z. So z is the variable. Now we're going to find h of a. Don't let that bother you. All that means is where you see an z, that z is going to be replaced with an a. And then there's nothing to work out on this problem. You don't have any like terms, so you just get a minus 8 over a plus 8. So that would be how that function evaluates. You have a variable, you can exchange one variable for another, and there's reasons why we do that in math. Okay, next one's kind of the same way. We're doing f of negative x. Now when you do this, notice the way I do this. I build a framework. Everywhere I see x in the problem, I replace that x with a negative x. If you do it this way, then you're forcing yourself to write it out correctly. Okay, now you can kind of work this out the side. If you're doing negative x to the third, what that means is you're taking a negative number and multiplying it out 3 times. A negative times a negative times a negative is a negative. Anytime you have 2 negatives, you get a positive. So if you have an odd number of negatives, you're always going to have a leftover negative. So that is a negative answer. And x is just x to the third. Next one, bring the 3 down. Now if you do negative x to the second, you're doing negative x times negative x, which is a positive answer. So that'll be minus 3 times positive x to the second. And then when you subtract a negative, subtracting a negative is the same as adding. So you'd have that. So now your answer would be written as negative x to the third minus 3x to the second plus x plus 7. So you have to be a little bit careful with the number of negatives that you're multiplying. Okay, so the next thing is f of x plus h. So this one we're going to do f of x plus h. Now when you do this, write down the original problem, but replace the x with a set of parentheses. Okay, if you do it this way, you'll never fail. You never want to fail. So all you're going to do is replace these x's with x plus h, and then you have an algebraic expression that you need to work out. So the way we want to do this is, I'm just going to kind of do this, a couple of things over at the side. If I'm doing x plus h to the second, The best way to probably do this at this stage is just write it out twice and multiply by the FOIL. So first term, x times x is x squared. Outside term, x times x is xh. Inside term is plus hx. Last term, h times h is h to the second. These are like terms. xh and hx are the same thing. It doesn't matter what order you multiply two numbers. So you do that. You should know that from your background. So we have 6 times x squared plus 2xh plus h squared. Now we're going to distribute. So negative 4 times x is negative 4x. Negative 4 times h is negative 4h. Bring down the plus 1. Okay, distribute to get 6x squared plus 12xh plus 6h squared. Bring down the rest. Now all we got to do is just see, do we have any like terms? So it doesn't look like we have any like terms. Every variable is different. X squared, that only occurs once. XH occurs once. H squared once. X and H. So they're all unlike terms. So that is evaluating a function. You took college algebra. You did that already. Okay, so this would be a good time to pause the video now and go down and do these 6 problems at the bottom. Okay. Okay, so I'll let you go ahead and check your answers carefully. On number 1, you should get 19. Number 2 is undefined. You cannot divide by 0. Okay. And there's a reason why. It's worth mentioning this. If you have a number like, when you're in like 3rd grade or whenever, you learn how to divide. 12 divided by 4 is 3. But you learn how to check your answer. That's right, because 3 times 4 is 12. Well, what if we had 9 divided by 0? And let's say that you don't know what that is. Well, the way you would check your answer is you would take your answer times 0 and see if you get 9. The thing is, no matter what you think the answer is, if you multiply by 0, you'll never get 9. That's why you can't divide by 0. It doesn't make any sense. Okay, same thing happens here on this next one. You end up getting 0 over 0. So all you worry about is the denominator. If the denominator is 0, you're undefined. The mathematical meaning of 0 divided by 0 is basically x can be, that the answer could be anything. If you think the answer is 1, well, it checks. 1 times 0 is 0. If you think the answer is 2, that checks. 2 times 0 is 0. If you think the answer is pi, that checks. Pi times 0 is equal to 0. So when you have 0 over 0, we still say it's undefined because you can't divide by 0. But technically, you can never get just one answer. You get an infinite number of answers. Okay, so the next one, you just essentially change the x to a. And then the next one, just like this, you just replace x with x plus h. And all I did on that after I did that is did a distributive property to get the negative 2x minus 2h. Can't do anything past that. And then the last one, you're going to end up doing a plus h squared minus 2 times a plus h. Again, you have to FOIL this out. So you can go through and look at the details of what I did on that. And there are no like terms on that, so that's the answer to the problem. Okay, pause the video anytime you need to. Okay, next thing we'll look at is the difference quotient. Now we look at the difference quotient because it shows up a lot in calculus, and for a lot of students, after pre-calculus, you take calculus. So this is what we call the difference quotient. You'll see that in calculus class when you learn about what's called a derivative. And what it really has to do is it has to do with a slope of a line on a curve that goes through 2 points. So here's how this goes. Basically, you have 2 points. One of your points is the point x comma f of x. So that is your first point on this curve. That's that point right there. The second point is x plus h. All h means is we're moving to the right. H is a positive number, so we're moving to the right. So we get x plus h and f of x plus h. Okay, that basically just gives you the second point on the graph. We use h, that's just kind of the standard. H is a number that's greater than 0. All it does is it adds to the x value, making it, giving another point on the graph. So you have 2 points. When you connect these 2 dots, you get what you call a secant line, and the difference quotient gives you a slope. So you may remember a slope formula that says you do the change in y divided by the change of x. That should be a formula that's familiar to you. So if we do the change in y, we're just going to do f of x plus h, that y value, minus the other y value. And then we do the change in x, change in y over change of x. So then we do x plus h minus x. The x's cross out, leaving you the expression f of x plus h minus f of x all over h. So that's how that goes. So one of the things you do in pre-calc is you want to learn how to do a difference quotient. Okay, so if you're asked to do a difference quotient, you're asked to do f of x plus h minus f of x all over h. So when you set this up, this is real important that you do it this way. Build a framework like that. Don't start these problems any other way. Now, what you're going to do is it's real simple. Whatever f of x is goes in the second place. So just pop it in there. That's it. Okay. Now, what goes in the second one is you get f of x plus h. And all that means is you're going to replace that x with x plus h. Do these problems like this. Put f of x in the second bracket and then make that slight adjustment in your first bracket. That's all over h. It's one big fraction bar. So what you'll have is you'll have 3x plus 3h, that's a distributive property, minus 4. Be super careful about this. Now see, this is like multiplying by -1. So -1 times 3x is -3x. -1 times -4 is plus 4. Then that's one big fraction bar all over h. Now what we're going to do with the difference quotient is you're going to simplify it. You're always going to find a lot of things cancel out. Always. If they don't, you're screwing up. Trust me. So we got 3 times h over h, and h over h is equal to 1. A lot of times students are taught to cancel. I don't like using the word cancel. I like you to think of it as removing a factor of 1. That's what we're doing. This is really, students never really think about this. You're just doing 3 times 1, so you get 3. That's a superior way to look at canceling. Canceling is kind of a bad term to teach students, in my opinion. Okay, go to the next page. Again, we set this up the same way. We're going to do f of x plus h minus f of x all over h. When you set this up, always, always, always start it the same way. Don't do anything. Just get it ready to set up. Now, you're always going to drop the function in the second bracket, because that's what the problem says, is the function goes there. So whatever you're given goes there. Okay? Can't go wrong. First bracket, what you do is replace all of these x's that you see with a set of parentheses, and all of these x's are going to get replaced with x plus h. So it's always kind of good that when you get this set up to just pause. Okay, I got f of x. Now I just change the x's to x plus h. Now the rest of this is a bunch of algebra. Okay, so if I do x plus h squared, I'm going to do FOIL. I did that before, so that's x squared plus xh plus hx, it doesn't matter what order that's in, plus h to the second. These are like terms, so you have x squared plus 2xh plus h squared. Now you can also say 2hx, who cares? It's the same. So we have x squared plus 2xh plus h squared minus 3x minus 3h plus 4. So I'm doing a distributive property. Be careful here. That will be minus x squared. Minus a negative is adding 3x. And then minus 4. That's a place where students mess up all the time. Now, find all the things that cancel. Again, they go to 0 in this case. X squared minus x squared is 0. If you add 0 to anything, it doesn't change anything. So I don't like to use the word cancel. 3x's go away, 4's go away. Write down whatever you're left with, which is 2xh plus h to the second minus 3h all over h. Now, notice that every term in the numerator has an h in it, so you can factor it out. And then you're going to be able to remove this factor of 1. Again, h over h is 1. Now, you don't have to write this step. Teachers never teach you how to write this step this way because it's unnecessary. But the answer to the problem is 2x plus h minus 3. Now, you will learn a lot more about what this expression means when you take like a Calculus 1 class. But in this class, we just get you comfortable with the algebra. That's part of the purpose of the class, is to get you strong with your algebra, because students typically are not very strong with their algebra when they get in Calc 1. We need to change that. That's why you do your homework nightly, every single problem. It's the only way to get ready for calculus is to work hard. Okay, go ahead and pause the video, see if you can do these two problems, and we'll be just about done. Okay, so you can look over what you got on here and make any adjustments if you had any issues with anything, and just check your work. Pause the video if you need to make any adjustments to that. But whenever I have you pause the video, please do that, because you will learn a lot more by doing problems on your own and then seeing if you did it effectively. Okay, all right. Next page, a couple of things. These are elementary functions that we'll, talk a little bit about from time to time. These are just graphs that are kind of helpful to memorize or be able to make a table of values very quickly. So this is called the identity function, or sometimes just a linear function, but it's y equals x. It's f of x equals x. And all that means is x and y are identical. Notice that in this table, their x and y are the same. You plot the points, you get this straight line. The next one is a squaring function. And again, you can do this all in your head. See, I'm just squaring these numbers. I'm doing negative 2 to the second to get 4, negative 1 to the second to get 1, and so forth. Plot the points, you get a shape that is known to be a parabola, which you've learned how to do before. Okay, next one is a cubic function. So what you're doing is cubing each x value. So I'm just choosing x to go from negative 2 to 2. If I take that and multiply that negative number out 3 times, that's going to give me negative 8. 2 times 2 is 4, 4 times 2 is 8. So you get that? That's what that graph of a cubic function looks like. Okay, next one is square root. And notice that I'm only using these numbers. I can't use negative numbers, because if I use the square root of negative 1, I get an imaginary number. So I'm just doing square root of 0, square root of 16. I just pick numbers that I know square roots of. Function looks like this. These are all functions. They all pass the vertical line test. Cube root function works like this. Cube root of negative 8 is negative 2. The reason is because negative 2 multiplied out 3 times will give you negative 8. So if you do the cube root of each of these numbers, you'll get these y values. And then absolute value, if you're doing an absolute value of a negative, that turns into a positive. If you do an absolute value of a positive, it remains positive, because absolute value is giving you the distance between a number and 0 on a number line. So these things are good for review. These things you'll see. We'll do a little bit of work with transformations of function in this class. All right, that'll wrap it up. Hope you enjoyed the musical introduction. Hope this helps, and please do your homework. Every single problem. All right, good luck.